Welcome to qnawire.
Alright, let's move on to the next problem. F is the vector given as 2y, xc, x plus y, and c is the intersection of the plane and the cylinder. The plane is z equals to y plus 2. The cylinder is x squared plus y squared equals to 1. And as you can see, it is going to be a slanted ellipse, rotated counterclockwise, and the normal vector is going, it's difficult to draw in here, but hopefully you can see that it's going inwards towards this the string. Okay. All right, so let's try to evaluate the integral. We are asked to evaluate the line integral f dot dr, but we can use Stokes theorem here. The double integral s, where s is the surface that we see right here. So to evaluate it, we will do curl f dot ds. And like the previous problem, we're just going to take the dot product with the normal vector ds. Okay. All right. So the normal vector, again, it's quite simple. We have the plane given to us. So from there, without getting a unit vector, we can say that n is parallel to the x is 0, the y is -1, and z is 1. Okay, we can also calculate the curl. Just so you know, I've already done these calculations, so normally it would take a little bit longer, quite more steps to go through the calculations, but don't worry about that portion. I just want you to be able to practice. But curl of f will end up being 1 minus x, comma -1, comma z minus 2. Okay, so we will calculate the dot product. Dot n. You will simplify it as z minus 1. So what we want to evaluate is the double integral through the surface S of z minus 1 ds. Now I am going to straightforwardly calculate this thing, but I like to parameterize the surface so that the projection is onto the xy plane, so that it's going to be a straightforward circle. The radius is r, the angle is theta. The usual parameterization where we use sines and cosines and the radius r to evaluate this double integral. So I will choose x equals to r cosine theta, y equals to r sine theta. And because z is equal to y plus 2, we can rewrite it as r sine theta plus 2. So what we're really evaluating is the double integral of r sine theta. This is z minus 1, so it's going to be plus 1. Okay, and let's not forget that this is the same as the change of variables, so we have to have an r in it. r dr d theta. Okay, the radius, as I mentioned, changes from 0 to 1. The angle theta changes from 0 to 2 pi. The rest is a very straightforward calculation, so I'll let you do that, but this will simplify to pi. And this is how you solve these kind of problems.